And who's got a question? Anybody think of a question? Yeah, Grace?
Can we do number 3 on the request?
Request. The original request, and which one is it? Number 3. All right, so we are doing on the just the regular request. We are doing problem number 3. So problem number 3 says that we have a parallelogram. And it's 6 and 10 and 110. And these are inches. And we want to find the length of the shorter diagonal. So this is the regular prequest. And we're doing problem number 3, find the length of the shortest diagonal. So I guess the first thing we have to do is recognize that the shortest diagonal is going to be this, right? We're going to find the length of that. Now remember, no assumptions about this division right here. They are not equal. My 2 fingers are not on equal angles. You can't make that assumption. So you're not going to use the 110 because you know nothing about it, but you know this one is 70 because adjacent angles in a parallelogram are supplementary. Okay. Now you're finding a length. You're not doing area, right? No, this is find the length of the diagonal. So to find a length, we use the law of sines or cosines, right? That's how you find length. That's how you find angles. We use the law of sines or cosines to find lengths or angles. So, oh wait, I erased something important. What am I going to use to find that x? Law of cosines. So it would be simply x squared equals 6 squared plus 10 squared minus 2, 6, 10 cosine 70. You're just going to type it in and hit square root, and you will have your answer. Don't forget to put a unit on it, so it'd be 9.74 inches if I typed it in correctly. I love confirmation. Would somebody confirm? Good. Okay. All right. Who else? Good. You got it, Grace? Okay, that. All right. Yeah, Jesus.
I have a question about the multiply. We're going to have to memorize all these, right? Like the equations?
You mean like for law of cosines?
Yeah.
Yeah, absolutely. There really isn't that much. I mean, you got to know the law of cosines and the law of sines, and you have to know how to find the area. 1/2 side sine, or Hero's formula, the radical one. I think that's all, though, right? I think so. Yeah. Okay. Who else? Who else has a question? I'm not going to stand here and beg. What do we need to practice? Yes. The law of sines? Sine A over A equals sine B over B. I mean, that's all there is to it, literally. We can do a problem using it. On this same paper, the very first problem at the top says how many triangles are possible. And that looks like this, the way the information, this is the information. So to do this problem, because of that right there, we're going to use the law of sines, right? So we're going to say sine 50 over 10 equals sine B over 4. And then we'll cross multiply and divide. Now, if you just type this in right here, you're going to get a decimal because this is not your answer. How do we get our answer? We need to find angle B. So we will have to do what? second sine, or inverse sine. So inverse sine, 4 sine 50, close the parentheses, divided by 10. And I got 17.84. Did you? Okay. So remember, your job specifically is how many triangles are possible. So because we got an answer, because sometimes we don't, because we got an answer, we know there's at least one, right? So then to find out if there's another one, you don't have to do any more trigonometry. If there is another angle or another triangle that fits this given data, the other angle B will be 180 minus the first one. So it'll be 162.16. Would that be possible? Would a triangle like this be possible? No. So there's one possible triangle. So all those, Tyler, are going to use the law of sines. All those problems that say how many triangles. All right. So what else? It doesn't have to be this sheet, any of the sheets. Yes.
So do you only look for a second triangle if the problem asks for it, or is it whenever you find the angle?
Whenever you
formula?
have angle side, you're going to have to check for a second triangle. So, and a clue is you're right. If you are using the law of sines to find an angle right off the bat in the problem, you probably are going to have a possibility of multiple triangles. Jesus, what are you wondering about? Oh, you're helping him? Oh, God bless you. Yay, good. All right. Feel free to wander and help others. All right, anything else? Oscar? On this same page, number 7. Shoot, I erased it. Oh, no, I sorry, didn't. Number 7 says, now find the area of this parallelogram. So it goes back to Grace's problem, only now we are finding the area of it. So in the beginning, that wasn't in there, but we're going to go ahead and put that back in there because we're going to find the area of the triangle and then double it. Okay, Oscar? Yeah. And to find the area of the triangle, this one is set up beautifully for that because I have 2 sides and the included angle. So my area will be 1/2 side times sine of included angle. Now, the only thing you have to be paying attention to, kids, is if you type this into your calculator, which is wonderful, that is the area of the triangle. So you got to hit times 2 to get the area of the whole parallelogram, right? Or some of you might get tricky and just leave that out, and that's okay too. Just make sure you're finding the area of the parallelogram. So the area of the parallelogram will be 56.38 square inches. The whole parallelogram. Okay, Oscar? Yeah. Is that right? Yeah, thank you. All right. Anybody else on any of the papers? The one we're working on is fine, or any of the other ones? What about number 5 on the same paper? Jordan is walking toward the trig tower. So here's the tower over here. At one point, her angle of elevation is 28. After walking 15 more minutes, her angle of elevation is now 31. How tall is the building? Didn't we look at these before? And so you're welcome. If you can remember what you did before, you're absolutely welcome to keep doing that. Now, though, we have some ways that are going to help us maybe do this a little bit more efficiently. Before, we had to look at only this triangle and the whole triangle, because we were focused on right triangle trigonometry, SOHCAHTOA. But now we know how to deal with triangles that aren't right triangles. So if you think about it, I know a lot about this skinny little triangle right here. I know this angle, for example, is 149. And that would mean that little tiny one at the top is 3. I also know that she walked 15 minutes at a speed of 2 miles an hour. So 15 minutes is a fourth of an hour. 2 miles an hour for a fourth of an hour. Distance equals rate times time. 2 miles an hour times a fourth of an hour. So this is a half. Right? Grace?
How did you know that the second angle was 149?
Linear pair? Your supplementary, a line is 180? Yeah. Okay. Now, I can't find X, but I can find this thing right here. I'm going to call this H. This length right here. From here to here, I'm going to find this. Because once I find that, then that's going to help me find X. You see what I'm doing? Now, how can I find H? I can use my law of what? See what you got right here? That's going to be sines. So sine 3 over 0.5 equals sine 28 over H. Now, one thing, I'm sure you all know this already, but just to make sure, please don't say something like sine 3 over 0.5 equals sine 31 over x. You can't do the law of sines in 2 separate triangles. It has to be all the same triangle. So sine 3 over 0.5 equals sine 28 over h. All right, so I'm going to go ahead and find h. Okay, so we've got what h is. I got 4.485. I'm just going to leave that number on my calculator, but is that what you got? 4.485 for that? Now, how will that help me find the question? How will that help me find x? Now, I can use the law of sines in this triangle, or I can actually just do SOHCAHTOA if I want to, because it's a right triangle. But the law of sines is fine. Law of sines works in every triangle, so it's no problem using that. If you were going to use the law of sines, you'd say sine 90 over that 4.485 number equals sine 31 over x. Now let's try not to use any rounded off information. Let's do our cross multiply. So x is going to equal that number times sine 31 divided by sine 90. But that number's already in my calculator, so I'm just going to hit times sine 31, close parentheses, divided by sine 90, which is 1. I got 2.31. And the unit on that would be miles. Pretty tall building, 2.31 miles. All right. All right, anything else? Look at all the problems on all the papers. Anything? What? 2B on that same paper. 2B says find the area of a triangle. 2B, we are given, it looks like all of the sides. So if we are given all the sides and we want the area of the triangle, what's our strategy? Hero's formula. Yep, so we draw the big radical, we put 4 egg numbers underneath it. First thing you have to do is disappointing. Your mother never would have done that.
That's true.
Your dad might have.
Yeah, that's true.
All right, here we go. What's the first thing we have to find if we are doing Hero's formula? Gotta find the perimeter of the triangle and then divide it by half, or divide it by 2. So the perimeter of the triangle is 36. So the semi-perimeter will be 18, and that is our starting number. Now, over and over again, kids try to put the 12, the 10, and the 14 in here. That is not what goes in there. You have to take 18 minus each of those. So 18 minus 14, 18 minus 10, 18 minus 12, in any order. Then we multiply them all together. Take the square root. I got 58.79.
Yeah.
If you know the area of the if you know all 3 sides, the easiest way to find the area is right there. You can do it other ways, but that is the easiest way. If you know all 3 sides. Read.
2C.
2C is another find the area. But it is not all 3 sides. In fact, we do not have anything we need actually to find the area of the triangle, because we can't do this because we don't know enough sides, and we also can't do 1/2 side sine because we don't have 2 sides. So what are we going to have to do? We're going to have to find another side, right? You're going to need to find a side, and that's possible. I want you to pay attention to the fact that you've got 2 angles here, so what do we know automatically? The other one, yeah. Anytime you've got 2, the first thing you should want to do, or the first thing you do want to do, is find that 3rd one. And now look, what do we got right here? A pair. So read which side you want to find. It makes no difference, but we have to pick one.
C.
So we're going to find side C. So we'll say sine 80 over 16 equals sine 48 over C. And we'll find side C by cross multiplying and dividing. And we'll just go ahead and get that side. That is not going to be the answer to the question. I got 12.07. Now remember, we're finding area, so now I think I have enough, don't I? Because what I need is 2 sides and the angle in between them. So my area is going to be 1/2, that thing I just found, times 16, times sine 52. Make sure that if you found side C, like we did, that you are using angle 52. If we had found H, then we would have to use angle 48, right? Okay, so let's not round that off. Let's just use this number. And I got 76.11. Is that right?
I have a question.
Jacob?
Yeah, so why would you have to use 48 if 52 is already?
Because the angle you use has to be between the 2 sides you're using. It has to be the included angle, the one that's between the sides. So whatever side you're using, you're gonna use the angle between. The answer will be the same if you use the right angle. All right, anything else? Raise your hand up.
Never mind. So what is that area formula?
To use this formula, you have to have two sides and the angle in between. And in this case, we did not have that, so we had to do the law signs to get it, so that we could find the area.
So if you have two angles on a side, what do you do?
You find another side, which is exactly what we just did.
Yeah, so you're always using the side angle side for area of the triangle, right?
Or Hero's formula, if you know all three sides, or 1/2 base times height, if you happen to have that information. Yeah,
We do number 4.
on the same page?
Yeah.
All right, number 4 on the last, or on the same page, the page we've been working on. Number 4 says, find the largest angle of a triangle whose sides are 9, 11, and 15. I just made up the A, B, and C. It's not part of the problem, but just so we can talk about it. My directions are specific. Find the largest angle. Which one is going to be the largest, A, B, or C? A, A, A. Why is A going to be the biggest? Because it's biggest, it's across from the biggest side, right? So, I mean, think about it, right? It's called the Hinge Theorem in geometry. The bigger the angle, the bigger the side. Okay, so now I know I need to find angle A. To find an angle or a side, I use the law of sines or cosines. That's how you do it. Every angle, every side, it's going to be the law of sines or cosines. The only exception is a right triangle where you have SOHCAHTOA and the Pythagorean theorem. Otherwise, law of sines, law of cosines. Okay? Now, which is it? Got to be cosines because we do not have a pair. So if angle A is my angle, I'm going to put cosine A out here and 15 squared over here. Right? And then in the middle is going to go the 9 and the 11 combination. Now, you guys are smart people. Go ahead and solve it however it makes sense to you, however many steps it takes you. But don't just type it in, because if you just type it in, you're not going to have A solved for. You got to figure out what angle A is. So you're going to have to do this probably in some steps. So go ahead and do it. Does everybody have at least some way to start? All right, so go ahead and start in some way. Eventually, as you solve this equation, you should get down to where you have cosine A equals, and hopefully, unless I made a mistake, it's 23 over negative 198. So then how do we actually get the angle then? Second cosine, inverse cosine. Don't forget the negative. I got 96.67.
You always have your timer set in degrees.
Yeah. Okay, Now, if this were a solve the triangle problem and I had to keep going, now I could use the law of sines if I wanted, right? Or I could repeat to find a different angle. But since it just said find the largest, that's it. We did it. It could say find the smallest, and you would do everything exactly the same, except you'd be looking for angle B, right? All right, anything else? Anything else we need to look at?
I have a question.
Okay,
So for the hero formula, you need to like know three sides, but you also like there has to be like angles involved as well because it's involved with all of some way.
now for Hero's formula, all Hero's formula is going to do is find the area.
Oh no, I know that, but you need like to know the three sides in order.
You only need to know three sides. You don't need any other information. Hero's formula does not require any angles. It's semi-perimeter times S minus A, S minus B, S minus C.
And then the law of cosines is similar to that, but that's when there's no angles involved at all on the three sides.
If you have a triangle where you know all three sides and you're finding an angle, it has to be law of cosines because you don't have a pair. Anytime you don't have a pair, you're going to use the law of cosines.
Okay.
Anytime you do have a pair, you're going to use the law of sines. All right. Okay. Well, let's stop there. This is a good stopping point.